Hello and welcome back to Machine Learning. I'm Jivita Christie, and in this video, we are going to study the association rule learning. And this is another technique other than clustering in unsupervised learning, and it also performs as a type of clustering, but it's not exactly clustering because in this you'll try to find some interesting patterns in the data given. So um, let's begin. And first, we are going to see how this thing helps in what you can apply this. So you can apply this in something called market basket analysis. Okay. Now, what is market basket analysis? In a store, in a grocery store, you might see that customers are having, baskets where they are putting different items, and that's where this the concept of market basket analysis comes from. So let's say that customer one has milk, bread, and cereal in his basket. Customer two has milk, bread, sugar, and eggs. Customer three has milk, bread, and butter. And there's yet another customer who has sugar and eggs in the basket. Okay. Now, what does the market analyst do? The market analyst wants to find out which items are frequently bought together. And if you notice all the transactions, all the baskets, you'll notice milk and bread are appearing together quite frequently. So what you will do, you will in your store, you will place milk in one section, and right next to that section, you will place bread. The idea behind this is when your customers come to your store and they want to buy milk, they will see that there is also bread next to the milk. And so some of them might be influenced to buy bread because it's such a commonly bought together item. So that is known as market basket analysis. But in order to be able to apply this, you first have to find out where it can be applied and which items are actually bought together. Now, since here you saw only 4 different baskets, it's very easy. But in reality, you have thousands and 10,000s of products in your inventory, and you will have lots of customers over a period of time. And if you have to analyze, you have to analyze the baskets of all the customers. In other words, you have to analyze the transactions of all the customers. So in that time, we apply something called the a priori algorithm. Okay. So the a priori algorithm helps you to find such items which are frequently bought together. And to begin the algorithm, we will be using this small example where I have 9 transactions. As you can see, I have 9 transactions with 100 to 900 IDs. And each transaction tells you which items were bought. So transaction T100 tells me that the customer bought I1, I2, and I5. In transaction T200, customer bought I2 and I4, and so on. Okay, we have to find out which of these items are frequently bought together. Okay, and to do that, we are going to take not just 2 items at a time. We could also take 3 at a time. We could also take 4 items at a time. It all depends on how you want to approach. Okay, so if you want to just find frequently bought items only 2 at a time, you could do that. You could also go to 3. You could also go to 4. So we will try to go up to 4 in this numerical. Now, to begin with, we have to define something called support. Okay, so support count shows you how many times items are bought. And we have to define something called a minimum support count. So let's define the minimum support count. The minimum support count we will have will be equal to 2. Okay, so any item that does not satisfy this minimum support count of 2 will be removed from the list. Now let's create our different items. So let's talk about first a list of items or combinations of items C1. And here I'm not going to create any combination. I'm just going to take one item at a time. So if you notice, I have 5 unique items. I have I1, I2, I3, I4, and I5. Okay. And for all of these items, I'm going to calculate the support count. So for I1, I can see I1 is appearing here, here, here. Okay, so you can say that it's appearing 7 times. Sorry, that's 6 times. So this is support count is 6. I2, 2, 3, 4, 5, 6, and 7. So support count is 7. I3 is coming here 1, 2, 3, 4, 5, and 6. So support count is 6. I4 is 1, 2, that's all. So I4 support count is going to be 2. And for I5, we have 1 and 2 as well. So support count for I5 will also be 2. Now from these combinations, we actually have to make a list L1. But as you can see, all these combinations, I mean, all these 5 items, they satisfy my minimum support count of 2, right? So that means I can include all 5 items in my list L1. Fine, let's proceed. Now let's create combinations of 2 items at a time, which means I will be taking I1 with I2, okay? If I removed some item from in the previous step, I do not have to include it here, okay? But I have all my items, so I'm going to include all. I'm going to combine all of them and create these combinations. So I have I1 with I2, with I4, with I5. Next, I can combine I2 with I3. I can also combine I2 with I4. I can combine I2 with I5. What else I can do? I can combine I3 with I4 and I5 as well. And I can also combine yeah, I think I missed one there. So let me just do that. This is going to be, okay, so this will be I3 with I5, and in the end, I can have I4 with I5. Order doesn't matter, of course, but you can, it would be nice to put it in this order, okay? Now let's calculate the support count. So let's say I1 and I2. So I1 and I2 appear in all these places, and so the support count is going to be 4. I1 and I3 are appearing in these places. So let's just count that. 1, 2, 3, and 4. This is also 4. I1 and I4 appear here. So 1. Okay, I1 and I4 appear in this position. Yeah. So that's it. For this, I will have a support count of 1. I1 and I5 will have 1, 2, and that's all, so 2. I2 and I3 are appearing here 1, 2, 3, and 4. So support count will be 4 for I2 and I3. Next, I2 and I4. So I2 and I4 appear here 1. That's all. I2 and I4 also appear here as well. So 2 will be the support count. I2 and I5. So it appears here, I2 and I5, and here as well. So the support count is going to be 2 again. Let's talk about I3 and I4. I don't see those appearing anywhere. So this will be 0. I3 and I5 are appearing only here. So this will be 1. And I4 and I5 are also not appearing anywhere. So this will be 0. So these are the support counts. And from here, I need to pick out the items that are frequent. So if you look at it, let me just highlight that for you. You can note from here that these items are actually not satisfying my support count of 2, right? And what other item does not satisfy? This one. This also does not satisfy the support count of 2. So we have to keep the rest of the items, but we will be removing these items marked red since they do not satisfy the support count. Okay. Now let's talk about what we can do next. So in the next step, we are going to combine and make 3 items at a time. You might ask, how do we do that? So first of all, you will pick the items you already have. So for example, I have I1 and I2 together. Now I have to find where in the rest of the items, other than the ones marked red, in the rest of the items, where do I have I1 or I2 coming? So I can see it's coming everywhere, which means I can combine all of those. For example, I can combine I1, I2, and I3 because they have I1 common. So I can make my first item as I1, I2, and I3. Next, I can also put I1, I2, and I5. So I'll put that as well, I1, I2, and I5. Next, I can have I1, I2, I3, but that's already there. So I1, I2, and I4. I could make combination of first and last, but that would give me I1, I2, I5, which also I have. So we'll not consider that. And let's now talk about I2. So I2 is common here with this one, but we've already included that. So could you include anything else with I2? So you can have I2 and I4, which are common here, or I3, which is common here. And that could give you one more set of items because you have certain things still common. So for example, you could have I2, I3, and I4 because I2 is common here. So you can have I2, I3, and I4. It is not, we haven't included that before. You can also have I2, I3, and I5. So I2, I3, and I5. And if you notice, we do not have any more triplets left to make. So we have found all the possible 3 combinations that we could make. Now, out of these 3 combinations, before we proceed and calculate the support count, we have to make sure that each of the individual pairs also are also present in the frequent item set. What does that mean? So let's take a look at the first one. First one is I1, I2, and I3. So I need to go back and check my list and make sure that 1, 2, 2, 3, and 1, 3 are present in the list. So let's take a look at that. We have 1, 2. We also have 2, 3, and we also have 1, 3, which means we will keep these 3 items together and calculate the support count. Which will turn out to be 2 because they are appearing twice. Okay. Let's also once again go back and now calculate for I1, 2, and 5. Should we keep it? So we need to have 1, 2. We need to have 2, 5, but we also need to have 1, 5, which is also present. So that means we can keep this. So we can keep this and we calculate the support count of 1, 2, and 5, and you'll notice 1, 2, and 5 are appearing twice. So 2 times. Let's take a look at 1, 2, and 4. So we need 1, 2, 2, 4, and 1, 4. So 1, 2 is there, 2, 4 is there, but 1, 4 is not present in this list. Okay. 1, 4 was there, but we removed it. So we cannot keep this item. This will be removed. 2, 3, 4 contains 2, 3 contains does not contain 3, 4. So we can remove this as well. 2, 3, 5. So 2, 3 is there. 3, 5 is not there, however, so this will be removed. So the only items we have in combination of 3 will be these items. What do we do now? We could also create a combination of 4 items. What can that be? So if you combine these two, you can see I1 and I2 are common. So you can create another item, I1, I2, I3, and I5. But then when we look at the list, these appear together only in one position. So the support count for this will be 2, and that means I can remove this. Sorry, the support count for this will be 1, and that's why I can remove it because it does not satisfy my minimum support count. So that's it. We've got all the items that are appearing together with a support count of 2 or more. And now we need to find out which of these forms some or the other frequent pattern. So to do that, first we are going to consider the last iteration that we did, in which we found these two items. We got I1, 2, and 3, and I1, 2, and 5. So let's talk about I1, I2, and I3 first. Okay, I could split it and create conditional probabilities like this. Um, Now what we're going to apply is something called confidence. So confidence, let me first give you the formula. So confidence of A given B. In other words, we are talking about the conditional probability of A given B, which is like this. This will be the support count of A union B divided by the support count of A. This is what it is. So we'll be applying this formula. And just like we defined a minimum support count, we will also be defining a minimum confidence. So let's say that the minimum confidence I want is 70%. So if something is 70%, it's interesting and worth implementing, otherwise it's not. Okay, so let's talk about the first set of three items we got, which was 1, 2, and 3, and calculate conditional probabilities for all cases, which means you will be dividing this 1, 2, and 3 into several parts, parts of 2, and you will calculate the probabilities. So that means you can have I1 and I2 given I3. You can also have I1 and I3 given I2. You can have I2 and I3 given I1. And you can also have the opposite, which means you can have I1, I2, and I3 on this side. And on the other side, you can have I2 and I3. You can have I1 and I3. You can have I1 and I2. So you have all these options here. We have to calculate now the confidence. So how do we calculate the confidence? It's quite simple. You just have to refer the tables you previously created. What this means is I1, I2 given I3. So if you remember the formula, on the numerator, we take the support count of all the things on the left side and the right side. So we will be taking support count for I1, 2, and 3 everywhere. What is that? That is 2. We calculated it here, right? So the support count everywhere in the numerator is going to be 2. Okay. Now we just need to put the denominator, which will be I1, I2, which we can find from the list of 2 items. So I1, I2 was 4. So let's put here 4. This will give me 50%. Okay. The next one is this. So this will be 2 by I1, I3. I1, I3 is also 4. So this will be 50% as well. Let's talk about I2, I3. So I2, I3 was 4 also. So this one also will be 2 by 4, 50%. Okay. Now let's talk about this one. This one has only I1. So I just have to see how many times I1 is appearing. And I counted that in the beginning. I1 is appearing 6 times. So this time I just have to write down 2 by 6 in this case. So this is going to be 2 by 6, okay, which gives me 1 by 3. And that would be something around 33%, but it's not 70. So we don't have to worry about it. Let's see this one. So this will be also 2 by, I think, support count of 2 is 7. So 2 by 7. We don't have to find the percentage. We know it's not going to be 70. This one will be 2 by item 3 is appearing 6 times. So once again, 2 by 6. This will also not be 70%. So that means none of these patterns satisfy our confidence, minimum confidence. So we are not going to consider any of these items. any of these patterns. But let's consider the next one, the next frequent item set we got, which was I2, I1, I2, and I5. So let's talk about I1, I2, and I5. Okay. For I1, I2, and I5, I'm going to just go back and get the counts of all these variables here. So I need I1, I2, I need I2, I5, and I need I1 and I5. So let's just go back and find out the counts for, in this case, 1, 2, 2, 5, and 1, 5. So 1, 2 is 4, 2, 5 is 2, and 1, 5 is also 2. So let's just place all those values. 1, 2 is, this is 4, everything else is 2. And I would also like to list out I1, I2, and I5 individually. So I'll just go back to that table and list out those values as well, 1, 2, and 5. So 1 is 6, 2 is 7, 5 is 2. Okay. So this is 6, this is 7, and 5 is 2. Okay, let's calculate. So first, let's talk about I1, I2 given I5. This is going to be I1, I2, I5, which is 2. Divide that by I1, I2, which is 4. 50 percentage not included. Let's talk about I1, I5 given I2. So this is going to be 2 by I1, I5 count, which is 2. Now this is 100 percentage, which means this is a good pattern to follow. So this is included. Next, we have I2 and I5 given I1. So this will be 2 by I2 and I5 together. This is 100% as well. So this is also interesting. Next, we just invert all this. So we will have I1 given I2 and I5, which will make 2 divided by 6. This is not included. I2 given 1 and 5. So this is going to make 2 divided by 7, which is also not interesting and which is not meeting our minimum threshold. And I5 given I1 and I2, which will be again 2 by 2. So this is 100 percentage, which means this is interesting as well. So the patterns that we found interesting are these three, which means in my store, I can say that if someone is buying I2, they will definitely 100% buy I1 and I5 also. If someone is buying I1, they will definitely buy 2 and 5 also. And if someone is buying I1 and I2 together, then they will definitely buy I5 also with 100% confidence. So that's what the a priori algorithm allows you to find out. So I hope you understood all this, and thank you for watching this video.